In part 1 of this demo, 1.1, we covered how IGMP version 2 is handled by Cisco iOS routers. In this part of the demo, 1.2, we are actually going to see the same things, but on Junos routers. So let's dive right into it. And here is our topology. It's the same exact topology as 1.1. The only difference is this time routers 5 and router 6 here are now Junos devices. So these are VSRX devices running Junos 12. So just to make sure we are on the same page, these two devices are now Junos devices. So the designated querier, in fact, the only routers on the network are now Junos routers. These two devices still remain iOS devices. But if you remember, we treat them as literally as end hosts, so they don't take part in the routing protocol, unicast or multicast, and they are essentially just IGMP reporters. So those remain iOS, but on R5 and R6, we'll see some major changes now because these are now running Junos. So let's do some basic verification test. Let's take a look at the base config that I have on these Junos devices. So here's device R5. Let's look at the configuration of it. And as you can see, all I have in this configuration is just the interface with VLAN tagging, the sub interface, and the IP address on that interface. There is nothing else other than one important thing. This is an SRX device, which can act either as a firewall in flow mode or as a router in packet mode. So it's essential that if you replicate these tests, you do them in packet mode, because that's what I'm doing. It's packet-based forwarding mode right now. And this would be the command set, and if you change a default SRX device, you would also need a reboot for that. On R6, we should see something similar. Exactly the same configuration, other than just the IP address that has changed here. Now these two devices have not changed. Rec 100, Rec 200 are still Cisco iOS devices. So let's do some basic verification here, and let's ping the two directly connected devices, 56.5 and 56.6. So we have local connectivity right now. Now the funny thing here is, by default, and this is also true for iOS till you actually start PIM on a device, but Junos devices also do not run any IGMP. So if I was to run a packet capture, which I have been running here for a little while, I actually see nothing in it. So there is no IGMP of any kind running on here. To enable IGMP on Junos, you can actually do it standalone. So you do not need PIM or any multicast routing protocol. There is a separate set of controls for IGMP, and you can essentially just turn on IGMP. Now, as with most of the Junos configuration, that doesn't actually happen under the interface configuration. There is a separate protocol that you would configure, and you would configure the interface inside the protocol. But that's just a fundamental difference between how Junos organizes the configuration hierarchically and versus iOS on an interface-based or an interface basis. So the protocol here would be IGMP. So let's go ahead and turn on IGMP on both of these interfaces. So the very first thing I'm going to do is I'm just simply going to turn on IGMP here on 5 and IGMP here on 6, and then we'll see on the packet captures if anything at all changes. So on R5, it is going to be set protocols IGMP, and then you pick the interface that you want to turn it on. In my case, I'm actually going to show you two variations of this. So I'll turn it on GE 000.56 on R5. And I'll actually, let's go ahead and commit this. And for R6, I'll just turn it on every interface for now and for future. So I'll say set protocols IGMP interface all. And then I'll commit this configuration. Now let's see the packet capture here once R6 commits. And there we go, we have some IGMP traffic. Let's take a quick look at what is happening here. So the very first thing that R5 did here was it actually joined two groups. So it sent membership reports for two separate groups, and that was the all routers multicast. So this is 224.0.0.2, which shouldn't be unfamiliar. And then 224.0.0.22, if you think back to your IGMP V3 lecture, you would notice that this is the IGMP V3 join. So that is just something, those are the two groups that the router decides that it needs to join. After that, it's basically just a steady state, which is sending queries. So it is sending general queries at that point, and it just to make sure that nothing is lost up front, it sent actually 3 of them separated by about 3 seconds. After that, you actually see 56.6 or R6 come up. So R6 actually did the same exact thing. It joined group 2 and group 22, and then it is going to actually send a membership query. And once R5 sends a membership, so in responding to that general query, R5 will send membership reports, which it did, and it sent 2 for 22. R6 then also sent us that general query a second time. But what we should see from this point on is that they should have elected a designated querier. So once R6, and this is the same exact thing, this is RFC standard, so it doesn't really change between Junos and iOS. But once R6 receives that first general query from R5, it'll actually give the designated querying duties, or it'll relinquish those duties to R5, and it should not be really generating any more of these IGMP general queries. So let's take a look back at the packet capture. I see some more packets coming in, and this time I actually see that the general query is coming from R5. So R5 is sending the general query, and R6 essentially just responds with those 2 membership reports, because those are the 2 groups that it has joined. So it's not assuming that. So in Cisco, we were seeing there was an assumption that 224.0.0.2 is always joined. In this case, there is an explicit membership report that is coming in from Junos. It's just a little bit different implementation, if you will. So let's go ahead and verify whether what we think about the general or the designated querier, if it's actually true or not. So on here, I'm going to say run show IGMP interface. So here's my first interface, GE000.56. And there you can see R5 believes itself to be the designated querier. Now, if I do the same command on R6, I can actually see on GE0056, they agree on who the querier is going to be, and it is the lowest IP that is on the subnet, or the lowest IP that can generate queries. So if you hear a query being generated by a lower source address or source IP, then you relinquish those duties. Let's look at some of the defaults here. The IGMP query interval for Cisco, if you remember, was 60 seconds. Here it's actually 125 seconds. So again, there is just a configuration difference in the default. The other thing is the query response interval. So this would be the max response is 100 milliseconds, which is 10 seconds. So that's exactly the same. And the last member query count, remember this was for group specific reports, that also actually matches. So it is 1. There is something else called the IGMP robustness count, which I will cover in IGMP version 3. But that is all that's here right now. The last thing is the IGMP membership timeout. So this is how long you're going to wait for that membership report to be. You have to hear at least one membership report within this time before you time that group out. So again, let's take a look at the steady state, if something else has happened or not. But it doesn't look like anything else is happening. So it's just a general membership query, and then 2 membership reports always coming in for 0.2 and 0.22. And just so those extra membership reports don't bother us, what I've done here is I've actually filtered for IGMP, but not if the destination address is either 002 or 0022. So those two groups are now not going to be seen. So when we do the leave message, this may cause a little bit of a problem, so I'll try to remove the filter then. But for right now, for the join groups, let's just keep it out so that we are not looking at extra information. But when it comes to the leave group, because it goes to this particular address, I'll have to actually show that particular address actually going out as well. So now the next thing we have to do is to actually join some groups on Rec 100 and Rec 200. Just like with the iOS lecture, we'll actually join two separate groups. So we'll join two separate groups. One of those groups would be joined on both interfaces and one would be joined on one. So the groups are 239.1.1.100 that is being joined here. .200 that would be joined on Rec 200, and then .1 that would be joined on both the reporters. So .100 being joined on Rec 100, .200 being joined on Rec 200, and then .1 that is being joined at on both of the receivers. So let's go ahead and join those. That was actually an easy command if you remember from yesterday. It's iOS, so it's an interface-based command, intg00.56. And to join a group on the iOS router, it was IGMP join group. So let's go ahead and join that first group, 239.1.1.1. And we'll also join 100 here. And what I'll do is, so on Rec 200, we'll join IGMP join group 239.1.1.1, so that's joined, and 200 is the other group that we are joining here. Now what we should see are some membership reports that are going out on Wireshark. So there we go. There are membership reports now that went out for 239.1.1.1, 239.1.1.1. You sent it for 100. There's another one for 1. So again, you're sending multiple ones of these unsolicited reports just so that they're not lost in transit. There's another one for 100. And then 239.1.1, this is coming from Rec 200. And then Rec 200 joins 200 and sends reports for those twice as well. Now, here's the periodic general query coming in. So I didn't plan that. It just happened to time out the 125 seconds. It's coming in. And then you see the membership reports going out for all three of those join groups. Let's look at the membership query. This was one of the things that was tunable in iOS, which was how often you send it. And then the max response time. So again, go back to the IGMPv2 lecture and the iOS demo to see what the max response time did. But here I'm just going to show you how to change this max response time. So this is one of the items that you could tune normally, and also I'm going to actually increase the frequency of these general queries because waiting 125 seconds is just way too long to explain things. So let's go ahead and try to figure out where to place these variables inside IGMP on Junos. So set protocols IGMP, and one of the unique things you'll see if I actually go into the interface, so if I say interface G00 or GE0056, I actually do not see any knobs to change querying times. So in iOS, you could actually have different query intervals, different max response times based on different interfaces. On Junos, it's actually all global. So if you look at the global IGMP, I can actually change the query interval, the response interval, and also for the last member interval for that group specific message. So let's go ahead and change the query interval here. And let's change that to 30 seconds. We'll also change the query response interval. So this should change the max response time that is carried inside the packet. And let's change that to, I don't know, 15 seconds. Why not? So again, I just want to, yeah, so it's in seconds. So I'll say 15 seconds. And that's all I will do here, and I'll commit this information. So once I commit this information, now the query should be going out more often. And in that query, so that the very first query after my commit, so the query before the commit, 10 seconds of max response time. Right after the commit, this max response time has now changed to 15 seconds. So as you can see, it's rather easy, but it's only global. You cannot really do it on a per interface basis, but you can do it globally, and that would apply to all of the different interfaces on a Junos router. So what else? Let's look at the actual groups that I've joined. So I'll say do show, I'm sorry, switching between iOS and Junos. Run show IGMP groups. And these are all of the groups that have joined. So as you can see, we ourselves have joined 224.0.0.2. So when you see the source as quad 0, that just means that R5 itself is joining this group. So this is essentially R5 saying that they have joined this group. Also for 224.0.0.2, R5 has also joined this group. 239.111. So this is, yeah, I'm sorry, I think I'm just misreading this configuration here. This is actually, these are coming from R6. So I believe the source here means that you actually received those reports yourself, but these are actually coming from R6 and R6. So they're both coming from R6. Next you have 239.111. The field here is going to depend on who was the last reporter. So once again, go back to the iOS lecture to see how this actually takes place and how the random times expire. But this essentially means that the last report here came from 56.200 and not 100. And this can change over time. Then you have group 100. The reporter was rec 100. And then group 200. And the reporter was rec 200 there. Finally, you have the local groups that you've joined. Now, this is what I thought that the first one was, but these are the local groups. And the router has joined 002 and 0022, but we already saw the reports go out for these before. So we know that the router is actually explicitly joining these groups. So once again, looking at the steady state of this, it's quite simple. The general query goes out. The responses come back in, general query goes out, the responses come back in, general query, responses. So that's going to happen every 30 seconds or so. One more thing that I want to show here, which is to set up the debugs or the so-called debugs on a Junos routers. You actually have to set up the trace options. So let's see what trace options are actually available for IGMP. We'll say set protocol IGMP trace options. And now you need to flag what particular messages are you interested in, and then you have to actually send that output to a file. What I am interested in are, and it's a little bit more granular than what was available on iOS. So I want to see the queries, I want to see the reports, and I want to see just the leave messages. Those are the three that I'm interested in right now. So I'll say flag leave, detail, flag query, detail, and flag report, detail. And I'll only do that on R1 for right now. Then I'll say set protocols IGMP trace options file. So where do I actually want to send it to? And I'll call it TO_IGMP. So TO_IGMP V2, why not? So that is just a file that is sitting on the flash that will now, all of this trace option messages, they would be outputted to. So now we say commit, and it's going to take just a little bit of time. Now, as the queries go out here, I can finally then go, so just keeping a look here. So now you can see an actual general query went out. We haven't received any reports yet. There come the reports. I'm just waiting for 1.200 to also show up. But remember, it has 15 seconds now. So it really depends on how much of a timer did Rec 200 set for that group. So here we go. We should have some events now capturing these packets in general in the trace options, right? So it would be run show log, and then here is the file to IGMP V2. So let's take a look at that, to IGMP V2, and there we go. So it looks a little bit different, but it's essentially saying the same thing. It received so it is sending an IGMP version 2 query to 224.0.0.1 for a particular interface. And again, remember the group in there is 0 and the max response time is, that field itself is carried as milliseconds. So it's 150. So that essentially just means 15 seconds itself. Now you receive reports. So you first receive a report from 100 or Rec 100 for group 100, then Rec 200 for group 1. So you can see who won the race for sending reports for 239.111. And then you receive a report from 200 for group 200. You're also receiving those, remember in Wireshark, I'm filtering out these two reports, the 224.0.0.2 and 224.0.0.22 that our counterpart Junos device is sending, but those are actually seen here. So I'm actually receiving reports for 224.0.0.22 and 224.0.0.2. And after that, while all of this took place, you actually sent another IGMP query, and then you started receiving reports. But that's how you would actually do a debug or perform a debug on a Junos device. The very last thing left here is to leave a group. So let's first leave a group that I am the sole member of. So Rec 100 is the sole member of 239.1.1.100. Let's try to leave that group. So we'll say no IP IGMP join group 200. What we should see is a leave message go up. And remember, so to see that leave message, I actually have to take, it is sent to 224.0.0.2, so I actually have to take that out of my filter. So I'm capturing messages that are going out to, so I'm capturing actual messages that are going out to that address. So now I am capturing those. So I should be able to see that leave message, and then I should see a group specific query go out, and that group specific query should have a lower max response time. So that's what they call the leave query interval. So here goes. Looking at the packet capture, here's the leave group message. It's going out to 224.0.0.2. It's coming from Rec 100, and it is to leave group 239.1.1.100. Immediately my R5 sends a group specific query for actually no, so this is the response for to the general query, but there should be a group specific query going out right now. So there's the group specific query. Now remember, like I said in the iOS lecture, with 30-second interval and 15-second max response time, this particular message here is just an answer to this general query here. But this leave group actually generates this specific query, the group specific query for 239.1.1.100. And that's to see if any more receivers actually exist for that group. And you can see that the max response time there is quite a bit lower. So we can change this with the leave query interval, or the last host query interval, but that's what it is doing. And then these are more responses coming to that general report that went out. And then you can see it happens over and over again. And now nobody is reporting for 239.1.1.100. And it should soon be timed out, but I thought that timeout was pretty long here. So if I say run show IGMP interface, I can actually see that the IGMP membership timeout was 75 seconds. So it's probably gone by right now. So let's look at the groups here. Run show IGMP groups. and I do not see 100 here, so it has been timed out. So it has been timed out. If I look at my file, Igmp V2, it should see a leave message in here somewhere. So there we go. There's the leave message. And then there goes the group specific query. So you can catch all of this on the trace options as well. And now that we have left one group, the only thing remaining here is to leave the shared group. So 239.111, and I'll make rec200 leave that group. So I'll make rec200 leave that group, and what we want to see is a response to the group specific query coming from rec100 when it literally goes, wait, I still need traffic for this particular group. So I am going to leave group 200, and what we should see is a leave message go up, general query come back in from R5, and then immediate membership report. Because remember, the max response time for this group specific query is about 1 second. So we are actually going to see this happen quite a bit faster than what you would normally see. So, oh, and the group I'm leaving is .1, not 200. So here we go. Leaving that group, we should see quite a bit of activity here now. Here's the leave group message for 239.111. Here's the group again. Now this is once again the queued up reports that are going out. So here's the leave group. Here's the group specific query. And then almost immediately there is the membership report for 239.111. So rec2 wants to leave that group. R5 wants to make sure that there are other members still present for that group, and rec100 wants to make sure that it keeps receiving traffic for that group, and it sends a membership report for that group. Other than that, you can see that the implementation, apart from joining these two specific groups, 22 and 2, and the configuration changes, which are basically just philosophical differences between Junos and iOS, they are quite a bit similar to each other in the actual working. So it's an RFC based working, which actually just is pretty similar between iOS and Junos. So we saw how to do the debugs, we saw the packet captures, we saw all of the different mechanics, we saw the verification commands that you can do on Junos devices. And other than that, dive into set protocols IGMP and see what other knobs you can find. But for a general overview, this should suffice. I would like to thank you for watching this lecture. I hope you have enjoyed it.